excited to be here. I hope finish strong today. Thanks for hanging out with us. I think there's enough water to go around at this point, and well hydrated, I'm sure. So we do have a really interesting discussion here that I think if we do it the way I hope, we'll be able to integrate a lot of these cool ideas we've heard throughout the day. And joining us is Alexandre Godin, the lead technologist with Airbus Emerging Technologies and Concepts. Come on up, Alexander. And Miguel San Martin. And Miguel is the chief engineer for the guidance and control section at JPL, NASA's JPL. If you don't know that acronym, it's the Jet Propulsion Laboratory. Dealing with navigation control guidance for planetary spacecraft. It doesn't get any cooler than that. Entry, descent, and landing phase. Okay, so let's have a seat, gentlemen.
Thank you very much. Thanks.
Where I'd like to start is just to get a sense from you, Alexander, as what I think is really interesting about your role, which we've talked about a couple times now, is, you know, we were joking last night, one of the things he gets to do being in France is he can tell his boss, you know, I need to go hang out at the Louvre today to get some new ideas. And he said, yeah, that's my job. So you get to explore new ideas, new concepts. Tell us a little bit more about how that works and what kind of inputs you're taking to produce value down to the business you're involved in.
So basically, I'm in a team called Emerging Technology and Concept at Airbus, and our mission is to look outside of aerospace to identify technologies that could bring value to our business. So once we identify a technology which is interesting, we try to bring it inside Airbus, quickly prototype some system to demonstrate the value, and then we can decide if we want to pursue, if we want to invest more, if we want to build a more robust system that will be integrated inside our development cycle.
Okay, great. Okay, good. And how about you, Miguel?
Well, the challenges where I worked on is how to descend on Mars. I mean, that's where and how do we get the inspiration for that? It's just simply, whenever we get a problem, we just sweat it and we think about it day or night, so that we don't go to the Louvre. You know, I take the problems to bed every night, and you know, stay awake for many hours until we get it. So and you don't know when that moment of inspiration is going to happen. So the more you think about it, at some point it might happen, but there's no guarantees.
So tell us about your customers are who?
Scientists in the robotics side in NASA, practically from day one, from Explorer 1, the scientists are the ones that they have the desire to go explore, for example, Mars. And the engineering team have to figure out how to, you know, bring those instruments to Mars. And they are our customers, and they are very demanding. And if they, and from a technology point of view, and this is a technology meeting here, gathering, if they can actually do their science without innovating, they will be perfectly happy with that. So our pressures is to figure out how to innovate and convince them that if we do this, you know, if we adopt this in the next mission, that is going to cost some money and they might bring some mission risk. They're going to get more science out of that investment on that technology. Mm-hmm. And so we need to go talk to them. We need to take them, you know.
All right. So this is a really interesting point. Is it the need that drives the pursuit of innovation? Or does it, and I'm going to ask you the same question, but is that generally what's happening?
It's a push-pull, right? I mean, they need, you know, absolutely, you know, like for example, you know, Curiosity is the last rover that we landed on Mars. In order to just land all those instruments, we need to figure out new ways of landing. So that came from their desires. But then there are other places where we need to tell them that they have a need that they don't realize they do, you know, which I'm sure that is a typical problem in industry too. So we have to say, look, we can do this for you, and if you do this, this is what you're going to get more out of this mission.
Sure.
So this is us selling them something that they didn't think about.
In the case of Airbus, tell us how that works.
It's a bit the same, actually, and we try to make sure the business can meet the technology and the technology being a tool. It's not a hand, it's a tool to bring value to the company. So the idea is to multiply, to have several places where business people can really use, learn, be educated about the technology in order they can really concretely deliver value for the company.
So when you come up with new concepts or ideas, what's the channel you follow into bringing it to bear? What especially if it may seem to be particularly out of the box or just irrational or something?
So we have different type of structures at Airbus, and some of them are really focused on crazy concept, disruptive concept. So until those who are focused on really concrete stuff that are directly touching the aircraft itself, and my team is a bit in between. So we try to look what is disruptive, and we try to ease the way to inject it inside the product. So there's different type of processes and different ways to inject these technologies inside our aircraft.
Now, what I think is interesting is this panel is really about emerging technologies in the future, but my sense is, as we were discussing earlier, there's such a need to still overcome fundamental human characteristics. So the issue of breaking through silos, which we talked about, seems like that's never going to go away. So in the case of NASA, tell us how you overcome the inevitability of silos working separately and doing their own thing.
Yes, for example, we probably rediscovered, because probably in the beginning of NASA it was this way, that we needed to get a group of, for example, for the problem of entry, descent, and landing, what we call the 7 minutes of terror, where things have to go perfect, all automated, and if something goes wrong, 99% is not good enough. We realized that we need to organize a team around that phase of the mission. The mission to Mars has 3 phases. It's getting to Mars, landing on Mars, and then the real science on the surface. What we needed is a special team dedicated to those 7 minutes. And it was an interdisciplinary team. There was a system engineer that we call it the phase lead, okay? And this group of people, which usually don't talk to each other because they're mechanical engineers, computer scientists, guidance and control engineers, they are organized in this team, and actually socializing in that team is almost as important as everything else. We become, we go out for lunch, we go to the bar, and all of a sudden the information starts circulating, and then the ideas that require people from different disciplines talking to each other. And that has given us, and we try to collocate a group of these people and in the same building, and that has worked very well for us. I mean, it's hard. I don't think that we could have done it any other ways than just having this dedicated team. And now we actually move that same concept to the phase lead on the surface too. So we have different groups, integrated, multidisciplinary groups.
So Alexandre, how do you incent folks to get out of their silo?
So first, we encourage them to share their ideas, and we encourage them to participate to global communities around specific topics. And then if they have the good idea, which is selected, we try to push them to shape an auto-organized team from which they could develop their ideas. And this process, we call it sprint, which is a process deployed at Airbus for more than 4 or 5 years. And basically, the multidisciplinary teams involved in this process have 100 days to go from the idea, which was selected at the beginning, to the functional prototype that they will test themselves.
So one of the great panels today was on really sustainability, and I thought it was very interesting, the idea of trying to reduce waste in the product development cycles and things. So from the perspective of Airbus, how have you guys sort of tackled that issue?
So the idea was to shorten the iteration cycles in order to not waste our energy and investment inside subjects that would not impact or add value to the business. So if you can identify very early in the process that you won't benefit, you won't bring value with these technologies or with these systems, you can just stand by the project and do something else.
Well, I think we're all familiar with your end customer being a traveler, and we understand their needs. Now, your customers, the people writing your checks, are more fickle. They're lawmakers, right?
Yes.
And we know how tough that must be, but...
Yes, very tough.
Yeah. So I guess what I'm trying to get at is how do you ultimately, how do you sort of judge your value along the way? How do you sort of make sure you're bringing a benefit? And, being 30 years at NASA, I don't know if that goal line has changed over time.
No, I mean, I think that the NASA has a very clear culture. I mean, that we're sharing our, space experiences. I mean, we are very, very aware that the taxpayers is the one really footing the bill, and this is their space program. And also we have one of the biggest aspects of NASA is actually help with the newer generations, as the education and inspire the younger generations. So that's how I think that's a big part of the role of NASA, and just we just can see now with the social media and the web, we can actually see how people are really looking into our websites, and when we land on Mars, we get a lot of interest in all sorts of kids. So we can actually see it that way, and we permanently have people, schools coming to JPL all the time. So I think that's one way that we feel that we are succeeding or not in our business.
Did anybody hear what President Obama said about putting a man on Mars? Did anybody hear that recently? So he's saying by 2030 is what he's saying, right?
In the decade of the 2030s, we're going to send humans to Mars.
Okay, that doesn't mean the same as landing on Mars.
Not necessarily. I can only say that we are building, NASA is building a Saturn V class rocket, which is to take astronauts beyond Earth orbit. And actually, the Earth orbit activities is NASA is hiring the private sector, like SpaceX and Boeing.
Sure.
SpaceX and Boeing are going to start transporting for the first time astronauts to the space station next year. So the first time they're going to be NASA sure. Spaceship. And so then that liberates NASA government resources to actually explore beyond Earth orbit, which could be obviously Mars. And also they're building a capsule, which is kind of like a Apollo on steroids, much bigger. And with the idea that that's the capsule that's going to take astronauts to Mars. So we are going in that way. The next mission that is really, part of being funded is a mission to bring with a robotic mission, bring a big boulder from an asteroid and put it in lunar orbit for astronauts to go visit. So they call it the proving grounds, a way for NASA to exercise being outside Earth orbit, which we've been stuck since the 1970s, without going all the way to Mars. So that's the plan, that's in the books.
One thing I neglected to ask you earlier is reflecting on the history of our space program and well aware of what happened in the 50s with Sputnik and all this other stuff. Is there pressures from other countries out there in their space programs that's going to put pressure on us to accelerate?
I hope so. Sputnik resulted in a huge resurgence in educational system in the United States. They felt that there was a gap, and that's why Sputnik took place. And so the government spent a lot of money on education, and actually that paid off. And so I don't like the competition, because we should be doing this for science, and we should not be competing between nations. But if that's what we need for people to open their wallets and put money on these things, bring it on. So that's my opinion, by the way, not NASA's opinion.
Okay. One of the themes that Martin started the day around was build to discover. You go along the path and you're going to make new discoveries, but you have to commit to building in the first place. What's your thoughts on that concept, Alex?
I think it's very true. And what we try to encourage again at Airbus is people doing their own projects and prototyping their own system in order they can learn while doing it and they can accomplish what they want in the company. So it's bringing value to the company and it's bringing value to the individual as well.
Mm-hmm. How about you?
Yeah, early prototyping is essential. The sooner you get something going, even if it's not perfect, you move in the right direction, and that's going to trigger other thoughts, that you might not trigger if you wait until you have the full solution already done. So,
now you said something earlier about intellectual journeying. Is that official? Is that your term?
That's my term, but I mean, and also I call it the intellectual time constant, which is like it's part of my frustration that when there is a problem and the solution you might not get there without actually going through a certain path. You cannot make big intellectual jumps, right? For example, the technique that we use to land this big rover, the size of a car, almost a ton, this technique called the sky crane, it's a technique that it was not obvious. And we only arrived to that because we did other techniques before that. And it would have been very difficult to get to that point without having gone through the other ones. You know, it's kind of like you have to go through the intellectual journey and make all your mistakes, or just simply design this system and then find what the problem with that system until you arrive to a solution. Actually, that in theory, you could have actually jumped directly to that solution, but in practice, you have to actually go through all this. And that takes time. But as long as you're doing something, you know, you go in the right direction, you have some chance for the light bulb to go off.
Where does AI fit into your robotics at NASA?
Well, actually, on the spacecraft, not much, unfortunately. I'm embarrassed to admit. And we're a little bit stuck in the past because everything has to be so predictive. You want predictability. You don't want the spacecraft to wake up in the morning, well, I don't want to land on Mars today, right? Or you want to know exactly what's going to happen the day of the landing. The other problem that we have is to automate, the spacecraft to the level that you would like to do. You need to automate the science, which means that the spacecraft should be able to decide is exploring that rock to the left is more important than exploring that other, soil in that other direction. So and those are the decisions that scientists like to make, which are our customers. So they don't want to be automated.
Let's talk about the technologies for a minute, Alexander. So just beyond the traditional AI and a lot of stuff we hear, robotics and machine learning, are there things that you're sort of looking around, seeing, even outside of the typical technology disciplines that you think could be interesting?
Yep. So on our side, augmented and virtual reality are strategic axis on which we want to progress and that we want to implement in the coming years. So it's already implemented and we already have examples. Head-up displays for pilots is a good example of augmented reality. Virtual reality rooms to do design review, ergonomic assessment as well. We already have tablets for application, for review our quality check. But all of these are very technical, are very difficult to access, are very complex to operate, and in the coming years, in the coming months, actually, the objective is to deploy more commonly, to democratize virtual and augmented reality in order to take benefit of what is happening on the market today. So you saw Microsoft is launching a new platform, Intel is launching a platform, Google is launching Daydream. Every actor, every player in this field are launching big different platforms, and we need to be able to absorb it, to take the value out of it in order that our employee can benefit of it, and at the end, our customer as well.
So are these platforms fundamentally valuable in the testing and prototyping phases as well?
Yeah, so the idea is to use them for prototyping, but to implement them as part of our processes as well, in order the employee can really use them and take benefit of them for their daily work. And I can give you one concrete example. We developed with a partner a module, a software that can display in 3D in real time what the employee is designing in CATIA. So CATIA, which is our software to design our parts. And the idea is to de-risk at very early stage of the design of the parts, how it will look like in reality. So basically the guy, instead of having to go in very expensive and complex virtual reality rooms, he just plug on his computer an Oculus Rift or an HTC Vive, helmet that you can buy today on the internet, and he can directly access in real time to the 3D part he just designed on his own computer. So that way you de-risk a lot of different issues and you shorten the development cycles.
So this shorter development cycle concept, does that apply to your world? It's starting to. I mean, the fabrication part is not my area of expertise. We are trying to, we're bringing more automation tools like code generation, to the parts that is very monotonous in writing code, and all the infrastructural aspect of the flight software. We are now using tools. Also, we are doing computer tools for checking the software too. That's becoming a big thing for us, again, because we cannot have any bugs, because it can cost us a mission. I believe on the fabrication side, they're starting to use a lot of the 3D modeling and those things that are becoming very important in other industries.
Now, do you build your own software in some instances, or are you always acquiring from the outside?
The software on board the spacecraft is ours, but like for example, the operating system is a commercial product, so we some of the code checkers, automated code checkers, are built at JPL by experts in that field, and I believe they're pretty cutting edge at this point.
So one of the other comments during the day was Guibert was talking about how there's all this effort put in by coders to develop code, and it's done over and over again, from the very beginning. Is there any sense around reapplying existing code either within NASA or outside?
Oh, absolutely. Heritage, we call it heritage software. We have a lot of pressures to use heritage software because it worked in the previous mission and it's already finished, complete. And it's a big struggle because, the typical engineer that goes to JPL, they are there because they want to create new stuff. So you're always have to fight with the excuses of why the previous code won't work for the next mission. And sometimes it's almost funny to find out, what crazy little things that they try to grab on to be able to throw everything that's been done in the past. So I struggle with that with my engineers. This is, no, you're going to use that thing, and you have to prove to me that it's not going to work. So that's what we try to do: reuse previous software when it's applicable and when it was successful.
Do you have something like that as well?
Exactly. For example, when we do prototyping, we want to capitalize on all the software existing within the community of people that are actually developing software that works. Again, for augmented reality, for example, there's hundreds of thousands of people outside in the world that are developing softwares and code that works, that concretely bring value. So why to develop our own stuff if we could capitalize on work with these people that could already bring value from day one? There's no point.
Sure. Good. Well, let's. I think we can open it up for a question or two if you guys want to talk about. Yeah.
I've been waiting to ask this question of Miguel. So the New Horizons probe that went into Pluto, even though I just wanted to, kind of get a sense of that was a pretty exciting moment. 3 months ago. What were the implications there that you learned from that? Because that was like, they didn't really know what they were going to expect. And I'm just kind of curious how that impacts your work and what happened there.
Yeah, it was a mission managed by Goddard, which is not by the laboratory, not the NASA laboratory where I work, but it was a fantastic mission. And actually, they found out things about Pluto that they cannot explain. Period. They thought that Pluto, because it's at the edge of the solar system, that it was going to be a boring place with not much activity, but it looks like there is pretty much alive protoplanet or dwarf planet. They demoted it from planet to dwarf planet, and they're still trying to explain because they don't have theories. I'm not an expert on that field, but they're really flabbergasted by some of the stuff they saw. It looks like it's a much younger surface than it should be. It's something that is. Because if you're so far from the sun and it's a small body, there's not much activity. In the case of the moons of, for example, of Jupiter, you have the tidal waves, and that creates all sorts of volcanism and melts water, and it creates a lot of activity. But something that is hanging there at the edges of the solar system, it should be a pretty dead thing, just like our moon, but it's not. It's pretty much alive, and they're trying to figure out what the mechanisms are.
Yeah, I'm interested in what work you're doing to work with the private sector, the commercial entities out there today, like companies like NanoRacks who send up, different things to the International Space Station, and other
Companies like, which one you mentioned?
Oh, NanoRacks is just a company that, delivers things to the space station and other things in orbit. There are a lot of commercial entities out there, SpaceX, for example.
Yeah.
What type of things are you doing to collaborate with them right now, and what's on NASA's agenda?
Well, I mean, first of all, I mean, we always work with the private sector. With NASA, the vehicles that put men on the moon, they were built by the private sector. And actually, JPL is one of the few NASA centers that has the capability of building a whole spacecraft in-house. But we contract out with the private sector some of our missions. Right now, as I mentioned before, the plan was, let's give to the private sector servicing the space station. First with provisions, that was the cargo emissions to the space station, and then with astronauts. Okay, so that's huge. I mean, that NASA put a lot of money on there, and some people think that we are in a race with the private sector, but actually that was a collaboration. And then we already started for some of our robotic missions. We're starting to look at the SpaceX launchers because they're cheaper. So whatever is the cheapest thing to make our missions, then we use. So it's part of the tools that we have these days. So there's a lot of cooperation now as far as Mars, and Elon Musk plans to go to Mars. That's new. Right now NASA, that's a new world. I mean, I'm not sure what's going to happen with that.
Okay.
Yeah, just a quick note about the capsule that you were mentioning that will go to Mars and to the moon first, just to say that the propulsion module is being designed and built by Airbus.
Yeah,
Just
that's
wanted
correct.
to-
That's a
Quick shootout.
yeah,
That's
that's
it.
good.
Perfect.
It's a European collaboration, U.S. collaboration.
So you just took that point right from me. So let me ask another question, and this might be more important. How real life was the movie The Martian?
How realistic?
Yeah, how realistic?
It's
was it?
actually it was pretty good. It was not insulting to one's intelligence like a lot of those, because at least the guy tried. He tried to do something clever, and so actually, I mean, I enjoy. I mean, he actually came to JPL and interviewed a lot of, and for example, when they get Mars Pathfinder to talk back to Earth. I worked on that mission, and especially that part with the antenna. The book actually was much better, how they describe that. So obviously he talked to some of my friends, and he tried to do a good job. Obviously he had to take some poetic license because they need to tell a story. But at the end, he did a good job. The last 10 minutes he got tired, I think, of trying to do something logical, and then he was, pure Hollywood.
Sorry, and changing the subject. I think first for Airbus, then for Miguel. How difficult is to find the talent to develop the things that we are doing? Because as kids, we all want to be astronauts or something like that. But growing up, it's more difficult to understand how we can apply to work in this kind of companies.
Yeah, so it's a bit complicated, especially because what we do within digital technologies are not our core business at the beginning. So what we do actually is we work with human resources directly, and we involve them inside the project in order they can understand what are the skills and competencies that are required for the development of this kind of technologies and projects, and then they can scout on the market what are the people that could be relevant for this type of development. So it's really the process to involve the right people from the beginning inside the development process.
And just to follow on that, we'll get to the question in a minute. What are you beginning to look globally for talent, or maybe you're already there? And how do you begin to identify geographies that might help you get to where you want to go?
Yeah, so basically, we are present worldwide, so we try to scout worldwide as well. Basically what we do is, depending on the different projects we have in the different area of the world, we try to capture the key competencies from these specific areas. For example, in India, we try to capture interesting software guys that can help us to build simulation, for example. When in Silicon Valley, we have more technical and guy on technology itself. And yeah, it depends really of the area of the world.
Okay, good.
Good. You were mentioning before some prototyping that you were doing. Can you give us some examples, if possible? I'm not sure if...
For which guy?
For Alex, yeah, sorry.
So, some projects? Yep. On AR, VR? Yeah. So, for example, we just partnered with Microsoft this year to develop some prototype on the HoloLens platform. They just released last year. So again, we got key people to make a team of 8 to 10 members, and we got these guys to shape an entity that moved inside Microsoft engineering teams to develop several prototypes that we will test before the end of the year. So this prototype will be focused on training and assembly. So I can give you the detail of what has been done, but basically it will concern our manufacturing processes. So that's one side. Some other side concern flight tests, and we are trying to check how augmented reality could be used for pilot or for engineers during flight tests. We do the same for quality. So as I mentioned, we already have tablet application to do quality check. So basically you have a tablet and you have a camera on top of it, and you have to look on top of the world. And it's a bit difficult for operators because when you want to operate, you need your hands. So what's the point of having a tablet in your hand? So what we try to do is to get the same software, which is very nice and very robust, but embed it inside glasses in order you can see the information, but work with your hand at the same time. So these are a few examples. There's a lot of others, but the idea behind all of this is to have very concrete stuff, starting from prototype to industrial product, and very rapidly. So the time frame of development of this technology is only a few months, few years. So there's no point of developing a product in 5 years if the technology is not there anymore.
Thank you.
Other questions? One other thing, Alexander. Infrastructure must be such a constraint, right? For I don't know, or maybe not. How do you overcome that? There's certain countries that are willing to build massive runways and make it all happen. Where I live in Connecticut, you can't even get a cell tower in a lot of places. So, is it potentially a concern for countries falling behind who can't adapt for the infrastructure, or do you, in terms of the way you would manufacture, overcome the existing constraints?
So of course there's constraint, and for example Airbus is manufacturing the different part of the aircraft in different countries in Europe and assembling them in different sites. So all of this is well controlled, and we have a lot of processes and a lot of design resources to make sure it's optimized and to make sure we produce the relevant part at the relevant place. And of course in the future you could think that the aircraft could be printed at one single place. But for the time being, we are optimizing the movement of the part and the manufacturing different sites.
Okay. Now, Miguel, 30 years at NASA. Is there something you're hoping to see before your time is through? Anything that you're really excited about being part of?
Well, it would be nice to see, humans, walking on Mars. That would be nice. I mean, we've been stuck for too long in Earth orbit, and it's time to go back. I mean, I saw Neil Armstrong walk on the moon as a kid, and I expected that we have done much more than that since then. So it's been very frustrating that we are not making more progress on the human side. And on the robotic side, one mission that we've been talking for a long time, and slowly we're getting there, is taking samples of Mars and bringing it back to Earth in order to really determine if there was life on Mars in the past. It's too difficult to bring the instruments to Mars. You need to bring the samples of Mars to Earth. Okay, and so the first step of that is in 2020. We're gonna send a rover, and you're gonna take samples and put them in capsules for another rover to pick it up and bring it back to Earth. So that would be. This is a mission that we've been talking for decades now, and it seems that it's going to happen. Also, a little thing that it will be very cool in that mission is that we might fly a little helicopter. and that is going to be used as a scout to be able to go ahead of the rover, and so that the rover drivers can determine what's the best path beyond the horizon and then be able to move faster. So that's still not 100% approved yet, but the engineers are working really hard to put the first helicopter on Mars. So that would be pretty cool too. It's a very little one, by the way.
Just occurred to me that with all of the conflicts in the world and more divisions among people, do you think these types of activities do something for the human spirit?
Oh, absolutely. I mean, people might not know this, but I mean, there was a huge international, component to Curiosity, the rover that landed on Mars in 2012. The instruments came from Russia, France, Spain, and then there are all the other scientists that participate. So when we are about to land, and all these scientists come from all corners of the world. I mean, it's actually fun to hear all these different languages being spoken, and they're all behind the same thing. It's really nice to see, and I think that is good for humanity, of the human spirit.
Good. Well, I think that's a great thing to end on. Very hopeful belief. So thank you for your service at NASA.
Thank you very much.
Thank you so much, Alexander. Appreciate it.
Thanks for having us. Thank you.
Thanks.